Okay, we left off with example 6 in your notes. Why don't you turn to that one? You guys know my friend Kimball Blake? Kimball asked a question last hour. He said, will we ever do this exact problem in real life? The answer is no, you probably won't. So, then the question is always, why do we learn it? Tried to give you guys that speech last week. Or the nail gun story. Did I tell you guys a nail gun story? Yeah. Yeah, exactly. So, yeah, exactly. Oh, wait a minute. So I didn't tell you the story that went along with it. Oh, all right. Well, we'll have to wait for that. I must have told 4th hour. But the idea is it makes you stronger. It's like, why do push-ups in a, why do you ever do a push-up in a football game? When during a football game do you do a push-up? Okay, yeah. You ever do a pull-up during a football game? You do certain things to make you stronger. Math is push-ups for your brain. There you go. There's my 2 cents. Okay. Find the dimensions that give the largest area for a rectangle whose base is on the x-axis and whose corners are on the parabola y equals 12 minus 3x squared. Gotta draw a picture. Okay? Yes. We're continuing on for Thursday. So, in terms of new material, this is not stuff you had last year. 12 minus 3x squared, what shape does that make? Parabola goes upside down, shifted up 12 units. So I got this parabola. Boom. What do I draw on the inside? What shape goes on the inside? A rectangle. What am I trying to do to that rectangle? Starts with an M. Maximize the area. So area is equal to, in this situation, I'll write base times height. And what we're going to try to do is we're going to try to express the base and height in terms of just one variable. So if that coordinate right there is xy, A for the day, who can tell me what the base is equal to? Give me a hint. There's an x in it. 2x. Who said that? Nice job. Well, this spot right here would have an x value, right? This would be negative x, and the distance between x and negative x is going to be 2x. So you can see your x in one direction, your x in the other direction, so the base, the entire base is 2x. Good work. What's the height? Y. Very good. Now, I don't want to express it as y because if you were to take the base times the height, you get 2xy. And that's two variables. I want one variable. So instead of writing y, what could I write? Y is the same as 12 minus 3x squared. Yep, y is the height, which can also be written as 12 minus 3x squared. How come is the height y? All right, how about this? Let's say that this was, let's say x was 2, okay? How would you figure out what the height was if x was 2? you'd plug it in, right? You plug it in. So this is what we plug x into in order to get the height. That gives us height. How's that? So now I write my equation. I have area in terms of what variable? Which variable? ABC, XYZ, X. X. Equals. What's the base? 2x. The height? Distribute that through. I get 24x minus 6x to the third. True or false? That makes a parabola. False, it's a cubic. And there's a negative in front of the x third, so the cubic looks something like that. Okay. And we want to find the maximum, and we're given, this kind of shape. So we don't have anything that we can use algebraically to figure this out. We got to turn to our calculator. Calculator is the only way we can do this. When we learn calculus, we'll be able to do it without using our calculator. So all you people are saying, I can't wait till calculus next year where I don't have to use my calculator. Chris, you take a calculus next year? No? Very good. Very good. I just fail you from class, and then we'll just have you keep coming back. You'll be a super duper senior. Emily will be here. You'll have some friends. Emily, come on. All right. Okay. Let's plug it in. 24x minus 6x to the third. I plug it in, and I'm going to graph in a normal viewing window. Now, every hour I've done this, somebody has yelled, I don't have the same graph. Did you zoom in a normal viewing window? That's what I get. I can't see the top. I wish I could. Why can't I? Because my window's not big enough. That represents, the Y value represents the area. Let's just think about this, people. Could you fit this is shifted up 12 units, okay? Could you fit a 12 by 12 rectangle in there? No, that's way too big, right? 12 by 12 would be 144. Question. Go ahead. Did you press zoom 6? You probably put a squared instead of a cube. You didn't put an X in. So you got 24. You got 24X. It's all right. It's okay. Good question. No, it's just funny because nobody made that mistake before. Everybody else was pressing zoom. so it's good. No, yeah, it's a good question. All right, we're all good. All right. Should I mention your name on YouTube? All right. Okay, Krista D. Okay, so we've got that shape. As you think about the viewing window, you guys said a 12 by 12 box would not fit in there, right? Well, if it was 12 by 12, that would be 144. So I can tell you right now, if I put my window all the way up to or down to negative 144 and positive 144, that would be, totally enough to be able to see that graph. So I'm just trying to give you an idea of how to pick a reasonable value. 12 by 12 is way too big. So if we press graph now, we should definitely see it. As you can see, you can see it now, right? In fact, you might be like, well, that's way too much. I only need to see to there. Well, if you want to go into your window and change it, if you want to go, I don't know, negative 50 and positive 50, so it looks better, do whatever you want. There's my graph. Does it have a maximum? How do I find it? Second, Calculate. 4, maximum. Go up to my maximum. I go left bound. Enter. I go right bound. Enter. Enter on guess, and it gives me 1.15, 18.48. This spot occurs at 1.15 and at 18.48. Let's see if you guys can be the smart ones. What does 1.15 mean? It's the x value where the maximum occurs. What does it mean in terms of this box? Is it the length of the base? Is it the height? No, it only gives me a way to find that stuff, doesn't it? In fact, it says that the base is 2 times the x value. So the base is equal to 2.3 twice 1.15. A for the day, what does 18.48 represent? 18.48 represents the area. We have a function, area in terms of x. That's why we label it like we do, so we know what it means. The x value is our input. The y value is our output, and it represents area. The maximum area occurs when the x value is 1.15. That makes the base 2.3. So no, this is not the y value. If you want to get the y value, you have to take 1.15 and plug it into right here. The height is y equals 12 minus 3 times 1.15 squared. Anybody do it? 12 minus 3 times 1.15 squared. And I get 8.03. So this is interesting because neither 2.3 nor 8.03 actually come up in your answer. But, you know, we find them by using that 1.15. Are there any questions how I did that problem? Is there something you need to see again? Something that angered you? Going once. Twice. 3 times sold. Flip it over. We got 2 more problems. We're doing 3 today. Now we are going to talk about hockey. Do we have any hockey players in here? How about those Minnesota Wild? Do you know the record right now? I watched the Timberwolves last night. They're 5-2 right now. They scored 47 points in the first quarter last night against LA. I can't stand LA. You know what's funny when we watch LA? What? It's the LA what? The LA Lakers. How did they get the name Lakers? They came from Minnesota. I wonder how many people know that. There's probably not a single lake in Los Angeles. Why did you call yourselves the Lakers? Well, they used to be the Minneapolis Lakers. George Mikan was the big center. They were one of the best teams around. So, a hockey team plays in an arena with seating capacity of 15,000 spectators. With the ticket price set at $14, average attendance at recent games has been 9,500. A market survey indicates that for each dollar the ticket price is lowered, the average attendance increases by 1,000. Find the price that maximizes revenue from ticket sales. Maximizing revenue from ticket sales. Does that sound like a good idea? Does that sound like something you'd maybe do in the real world? It sure does. So let's talk about revenue real quick. What is revenue? Money. Money brought in. So if I'm at the hockey game, how do I calculate the amount of money that I brought in? Yeah, my revenue is going to be equal to the ticket price. So like right now, what's the ticket price? $14. and I would multiply that by the attendance, which was 9,500, and that would give me the revenue that I brought in. Now, obviously, I incurred cost, but we're just trying to maximize revenue. Not profit, just revenue. Well, I can't have tickets and attendance. I have to have everything in one variable. And so this was the best advice that my probability theory professor ever gave me. And it's going to be advice that you're going to get. Are you ready for it? When you don't know how to do the problem, just do the problem. Here's what he meant. And it makes sense. I don't know just what to plug in for TNA right now. I have no idea. So I'm going to model the problem. I'm going to start to do the problem. And I'm just going to try numbers. Right now, I've got $14. And I multiply that by what? 9,500. Okay, so I did one. Well, let's change it and see if we can understand what's happening. Now I'm going to do revenue is equal to, we're going to take 14 and subtract what? What are we lowering it by each time? $1. So I'm going to subtract $1. And then I'll have 9,500 and what? Plus 1,000. How about 14 minus 2? If I lowered it $2, then I'd have 9,500 plus 2,000. If I had 14 minus 3, I'd have 9,500 plus 3,000. Well, so that's what my professor meant. When you don't know how to do the problem, just do the problem. So start writing out how it would go. Start writing out how you'd calculate it. And after a while, you might see a pattern. And you might be able to actually write a function. Anybody want to guess what the first part's going to be? Does the 14 ever change? 14 minus x. Very good. Perfect. See? I mean, I could have told you, I could have said, well, you know, we're going to start with $14, we're going to subtract X number, and we're going to multiply that by 9,500, we're going to add 1,000 X number. But that doesn't make sense, does it? I mean, we just talk about it. But when you model it, when you actually do it, you don't know how to do the problem, just do the problem, then it starts to make sense. And so that's how we write it out. So let's FOIL this out. R of X is equal to, when I multiply this out, I get 14 times 9,500. Now, because I've done this problem already today, I do happen to know that that is 1,000. I'm sorry. I do happen to know that's 133,000. And I do 14 times 1,000x, which is 14,000x. I do negative x times 9,500, so negative 9,500x. Add those together and you get 4,500x. And what's negative x times 1,000x? Negative 1,000x squared. So that's my function. What shape does that make? Parabola. Writes it up, upside down. Upside down. Draw my upside down parabola. It has a maximum. That's what I'm looking for. We know how to find that maximum. How do you find the maximum of a parabola? What formula do you use? Negative b divided by twice your a value. What's negative b? Divided by twice a. Negative 2,000. Very good. Your a value is sitting right in front of your x squared. So negative 4,500 divided by negative 2,000 is going to be 2.25. So the maximum occurs when the x value is 2.25. What does that mean in context of the original problem? What does that mean in context of the original problem? 2.25. True or false? In order to maximize my profit, I should charge $2.25 per ticket. False. That means I decrease the ticket price by $2.25. That's what we set it up to mean. So, ticket price equals 14 minus 2.25, which is $11.75. What do you think of that? Now, I would probably want to lower it even more. Do you know why? Because if I get more people to the game, what do they buy? Concessions. That's where I really make my money, right? I want to sell concessions. So you can see that problems like this can get rather complex. Sometimes we involve more than one variable, and that's where the study of operations research comes in. Yep. Yep. You can put restrictions that say, we're not going to go any more than 15,000. And that's what, so as you move on in mathematics, again, there's a course, it's a big book over there called OR, Operations Research, based on the linear programming that you did last year, Miss Nelson's class. Do you remember linear programming? You guys drew graphs, and you had all these inequalities, and you had to shade them. And you had to find your points of intersection and plug them into your objective function. Yeah, do you remember that? Wasn't that cool? I so want to teach that in pre-calc again. I always used to, but I just can't fit it in due to time. But that's what operations research is. And instead of having so you guys only had two variables. You generally only had x and y. You could have, one problem I did there, actually I got the paper over there, 126 different variables. So, it's cool because you're working the 126th dimension, even though you don't know what that means or looks like. So. I know you're excited, Carissa. You just want to do more problems like that. Good times. Okay, last problem, number 8. A rectangle is inscribed in a semicircle of radius 16. What should the dimensions of the rectangle be in order to maximize the area of the rectangle? I draw my shape. What is the shape? A semicircle. It has a radius of 16, so I know that all those points are 16. What do I draw on the inside? A rectangle. I guess we've done a problem kind of like this, so I'll write the xy. What formula should I write? Area equals base times height. Well, now I got to come up with expressions for base and height. Who's got base? 2x. Who's got height? Okay. Obviously, we need something more than y. Well, like this point right here, is this point more than 16 or less than 16? It's definitely lower than 16. 16 minus y It's a good idea, but fortunately it doesn't work. Anybody? Did you notice that before you had an equation? Did you remember that before you had this y equals 12 minus 3x squared? You don't have one of those, do you? We got to write an equation. We got to write an equation for a semicircle. Do you remember the formula for an equation for a circle? What's your center? Center at 0, 0. So x minus 0 is just x squared. Y minus 0, we get y squared. What's the radius? 16. If you square it, you get 256. X squared plus y squared is 256. Now again, what variable do you want to solve for? We want to solve for y because that gives us our height. And we could solve for y by subtracting the x squared. Y squared equals 256 minus x squared. Square root both sides. When you square root a variable, you get two solutions. Positive and negative square root of 256 minus x squared. Everybody wants to take the square root of 256 and the square root of x squared and write is just 16 minus x. Unfortunately, it does not work like that. You can't distribute powers over addition and subtraction. That's worse than reducing parts and getting your fingers cut off. So if this is my semicircle, is a circle a function? Does it pass the vertical line test? No. Does a semicircle pass a vertical line test? Yeah. So you can see the positive portion is the upper part of the circle and the negative portion is the lower part of the circle. So we've got the square root of 256 minus x squared. That's our height. Well, that's the most difficult part. Now it's easy after that. I write a function for area in terms of what variable? X. What's my base? Height. 256 minus x squared. Do you know what shape that makes? I don't. It's got this square root piece in there. It's got an x in front. That looks really complicated to me. So we don't have a formula for this, so we just go to our calculator. 2x square root 256 minus x squared. Before I even graph this, I'm going to go straight to my window because we've learned that we have certain constraints. You tell me, everybody, what is the largest your x value could be? 16. So I don't see 16 here. So I should definitely move this out. Negative 20, positive 20. That way I can see all of my x values that I want. I go to my scale. I'll make it 10. My y minimum. Well, let's think about this. Y represents the area. Area is the output. Let's say you had a 20 by 20 box in there. Okay? That's a pretty big box, isn't it? 20 by 20, what would that give you? 400. So, I'll just pick 400. I'll have a scale every 100. Now I press graph. That's a pretty cool shape. It doesn't. Your calculator is not smart enough to draw it. It actually does go right there as well. Okay. So if I were to draw it, the graph looks like this. That graph does have a maximum right there. I now need to find that maximum. So I can calculate number 4. All the way up. Need to move to the left. I move to the left. Move to the right. Move to the right. Enter on guess. 1131 and 256. Somebody please tell me, what does the 256 represent? Area. The maximum area is 256. That's the maximum area. 11.31 is the x value that will make that happen. If 11.31 is the x value, what is the base equal to? 22.62. Good. And the height is going to be equal to, I have to take that 11.31 and plug it in. And I get 1131. Done and done. We've seen 8 problems now that apply to different types of shapes, different types of situations, working on maximizing, minimizing. These are essential as you move forward into other areas of study, such as calculus. You have a full work day tomorrow. Here's what I want you to do today. You have a couple options. If you want to work on the problems that I taught you, then use the 5 from the other day. A couple of those have a twist and turn to them. You might need help, but 27, 28, 32 is what I'm adding to your assignment. Now, from your assignment they gave you before, or this one today, if you would like to just do these challenge problems for the fun of it, or if you would like to take off some of the previous problems, like let's say you say today, you're like, I got everything we did today, I don't need to practice any of that, then fine, get rid of these 3, don't do them, and try the challenge problems instead. But 26, 29, 34, 35, those, they're not impossible. You might do one and find it was easy. But if you want to push yourself, then go ahead. You might find it interesting. It's up to you. Solutions are in the manual. I will be here before school tomorrow. And again, you have a full work day tomorrow.